Okay, this is Tim Lawless from CS211, sort of walking you through my MIPS homework assignment for homework number 5. So, according to the assignment, I'm expecting to generate a random number that is a double precision floating point number, and I will fill a 20 element array. So I've left in some of my little commented notes. I will submit a version of this much more cleaned up in a Word document, but to sort of take you through this up here, this area where I'm sort of initializing memory values, I'll just try to point out a few things that I discovered or found along the way. Before including this little tag here, or whatever, this little command align 3, I was having problems placing these double numbers into the array, telling me that basically the memory wasn't aligned to fit the array properly. So I did a little searching online of that error, and I found this. If I take this away, you can see that in some senses it's almost as if I'm setting a type or preparing the subsequent data to fit into a certain structure, and by putting this 3 in here, it sets it, the array is essentially prepared to take double values. So I put that in there, and that pretty much took care of that problem. I've got a few ASCII characters that are really just to format, make things look good, and setting aside 20 by 8 bytes, 20 8-byte elements in memory for the doubles. So let's see here. So basically the way this works is I make a prompt to get the seed data for the random number, and then I have 3 separate functions that take care of each step along the way that we need. So I'm placing the result of the prompt into A0 as my argument register, and I go into this random number function. So right here, I'm whether or not it's necessary, based on, I guess, sort of good form, I've been trying to just save whatever of these S registers I'm going to use for the function, put that stuff on the stack, and take it off at the end of the function. So what this really does is it just simply does the arithmetic with these literal numbers that were in the random function that you included in the assignment. And one thing that sort of came up was thinking about after this multiplication, would the result fit in, would it spill over into the high register from the high-low? And I did some testing, and it seemed that generally speaking, I could just pull the product of that multiplication out of the low. So that's what I do here. So one little area I ran into having a little problem with was that after the division, and I got the modulus from those 2 values, S2 and S3, and I needed to be able to divide that by 1000 and have it be an actual random double. I had to move to coprocessor double, so I had to send that mod value over to F2 in the coprocessor, and I also had to use this convert. This would be, I guess, convert word to double word after that to make that actually work. So from here, I just chose to put this value 1000, this double 1000, in memory already. I probably could have done that as some kind of a immediate loading, and immediate, but that was there for me. So I did the division, and that placed in F2 my random number. So restoring the stack and jumping back up to my fill array. I never had to put any return addresses on the stack because I don't have any branching. I don't quite remember the name, but I don't have any functions within functions. So here we jump down to fill array. Fill array again, I'm expecting to use these S registers, so I throw them on the stack. Set my array base. I'm going to do a loop here to sort of increment that S value, S1 value up, to increment that up by 8 each time to load up my array. I've used this logical AND here to just clear out my 0, initialize that to 0, clear out my S2 and initialize it to 0, and then my my terminating value, which is my array length, put S3. And basically what happens is this line here puts it into memory. This does the incrementation, and if we have not reached the terminating value, we jump back up to the fill loop. So we do that until we reach 20. At that point we collapse our stack, jump back up, and the last part of this one here is the print array. So it's almost the same process, a very similar loop. We're just iterating through the memory now. So here's print array, and print array has its own print loop again. So in here again, throwing stuff on the stack that I expect to use within the function. Again, loading the base of the array, loading the length, and initializing a counter variable. And here again, sort of just adding some character output that sort of formats it to look a little bit better. I'm printing the, for instance, I'm printing the counter variable within 2 square brackets, so it sort of has a similar looking output that you would have if you were to attempt to just print an array out in Java. So adding these braces, square brackets, incrementing here, and I think the line that actually does the printing, I found, is that this by placing a double, like from here, from memory, into this F12 register, seems very similar to maybe the argument register, and by placing the 3 in the V0 register, system call prints that double to the console. So we jump back up to the top, and that basically kicks us back out to this exit. This is, I suppose, not probably necessary here, but I included it anyway. So that's it. Let me give you a little demonstration of it here. So I'm going to compile, or assemble, excuse me, and run it. And I'm going to enter the one from the assignment, which I think was 9973, I believe. And we'll just run that at full speed. And you can see here, I've got the value 7.002, and this is contained in each of the array segments. So just to keep this video sort of short, I made a variation on this. While I had sort of a theory on a way that we could continue getting different random numbers for each one of these, I noticed that you had a extra credit question or proposal where talked about sorting the data, which would not really work in this interpretation that I've chosen here. So maybe I'm interpreting the assignment wrong, but for now this seems to be working. So I will record another video and include that. That's just going to show the variation that I made on this program.